Hey guys, I'm going to do another battery build here for you. So I bought some of these packs from Battery Hookups, kind of like the packs I've done before. I really like the higher capacity cells, and when you can get them even used out of medical equipment, they usually have most of their usable capacity still. I've really had really good luck with the ones that I've been using in my Enduro, so I thought I'd make a bigger pack that's a little bit more space efficient. So these are 7.2 volts, kind of like the ones I used last time, and they're 46.9 amp hours. So there's a total of 14 cells. There's total 28 cells, 14 that are paralleled, two sets of 14 paralleled. So you have a 14 parallel 2S basically. And one of the big problems if you're wanting to use these for higher amp applications is you need to add more thicker nickel strips, because these are super thin. They're really not designed to handle a lot of current. So they come just like this though, which is pretty cool. You just take a razor blade and slice it so that you can open it up like this. And I like using these protective shells when I can as I'm working with them, at least initially, but you can use these for all kinds of different things. So you can see these are the NCR 18650B cells, and they're rated at 3350, I think, 3,350 milliamps. In my testing, I've been getting around 3,000 out of them, from 3.5 to 4.2, or actually a little less than 4.2. So they're like 3,000 milliamp cells, and they come out to around $1 a piece. They sell these for $28 on their website, and with shipping, usually it's a little over, but usually you can use like that 5% off discount coupon that they tend to send you all the time if you're a subscriber to them. So it ends up being around $1 a cell, and really there's not much to disassembling them if you want to use them as a, in other configurations. They Other than the shell that it comes in, which is a pretty thick rubber shell, they have a BEC board here that you can remove just by stripping a few of the strips off. So it's got a little tape, and then for my application I usually just snip these off. And like I said, it's such thin, they're such thin metal that you can just cut through it with a razor blade. And on this side it does have a temperature probe, so you just need to remove this tape and get that temperature probe out of the way. But really disassembling these and/or using them for like what I've been doing. So this temperature probe was kind of inserted into the cells there, and this one actually it shows you how strong their nickel. So this is the nickel strip right here, and their spot welds. The nickel strip is so thin that it just kind of came right off. But you pull this back, and kind of the same thing as the other side. I always just slide a razor blade in there and slice it off, and then depending upon how you want to do it, there's an extra little piece in here, so you can pull this tape off out of the way. And then there's just the one last piece right there. And That's it. So that's how you can get the BEC off. And you can cut that down more. Depending upon if you're going to use them for individual cells, you just strip all these off and you can use them for individual cells. Or you can configure them a bunch of different ways. You could do like 4 groups of 4, 4S, 4P. You could take some off if you don't want quite this many. You could take like, 4 and 4 off of it, off of the sides. But anyway, so this is what I was working with, and I'm going to make a 36 volt. So I needed 5 of these, and I actually make 2 36 volts because I'm a little freaky about the, shorting something out, and so 36 volts to me is a great voltage to work with. And if you just make 2 36 volt batteries, you can series the 236 together like I did on my Enduro, and that way I just run 2 smaller chargers, 36 volts each. It saves me a ton of money, and it's just safer. You're not gonna get hurt, or you're a lot less likely to get hurt. And then anytime you're not working with them, you could just put it back in the shell. Like with this, I'm going to use this 1/2 to go with a 48 volt battery I'm making. So you will have to split 1 1/2. You can also, take the metal strips off and then just kind of lightly sand the connection so that it's ready to go for another configuration. So they're pretty easy to work with. Doesn't take a whole lot to take them apart. I do sometimes it's hard to get them out without damaging the heat shrink that's on them. So you can get your own heat shrink and just re-shrink them so that you're good to go for individual cells for all your other applications. But anyway, so this is what I'm working on right now. I'm going to connect these 5 together, and kind of like what I was just showing you with that one, you can take it out and work with them individually in these shells so that you're a lot less likely to have a short or have any issues and stuff. So the way I've created the 36 volt battery, I've done most of it already. The first thing I do is I add a piece of nickel strip, 2.2 millimeters nickel strips, which will carry a lot more current. So on the one side, it just all needs to be connected together. So I'll run strips this way, and then I'll run a couple across just to make sure I have plenty of current. And then I added one of the BMS lines to it so that this side's done. That's all you have to do. I did this 5 times, and then I added some tape, some heat tape like this Kapton heat tape, just to keep it a little bit safer. So this side's done. The other side, I added the nickel strips to the half, but you need to be able to connect these to the ones next to them. So I've added the nickel strips to all of it, but now I'm going to connect them all together, and then I'll have a 36 volt battery. So that's my plan, and that's kind of how I do it to keep it a little bit safer. Is that way I do the one side, I did each of these one at a time, kind of individually. Whenever I just had a free moment, I spot welded a little bit more, and kind of took my time. So I have 5 that are ready to go on that side, and then if you put them together like this, the 2 on the end, so the 3 in the middle, that's all I had to do. The 2 on the ends, I had to add the actual power lead. So this one again is all done. It's got the BMS lead on that side, and And then, so then the front, the first and last packs, this side's all done just like the rest of them. But when I spot welded the strips on this side, I added extra nickel to come off the end, and then I soldered 10 gauge wire onto it with the connector. So basically I've got these all ready to be connected together. Everything's done except for connecting them together. So that way I don't have to risk as much touching things and maybe shorting something out. And then you just want to stagger them so that they kind of go boom, 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 like that. So the only thing left to do, now I've got the negative and the positive, and you can see the positive here, and then the bottoms all connect. All these, the bottoms are connected. So you've got the positive here, the negative connected to the positive of this one, and then you've got this negative that needs to jump over to the positive on this one. So that's where I need to spot weld the next sets of cross pieces, so that this one connects to this one, and then this one connects to this one, and this one connects to this one, and so on until you get to the other one. Now, this is the part that is the scariest or the most dangerous. So this is the part that you really want to take your time with. And that's why I kind of did each one individually just for safety purposes. It's like, all right, so I've got all the bottoms completely done. I got 5 of the BMS lines ready to go. And now the top, I'm going to connect these across to connect them together, each of them together. The positive and the negative don't need to be connected to anything. These two are the first and last, but all of these need to be connected. So I need to make 5 connections basically across here. And then once I do that, then I'll have the voltage coming through here. Then I'll add the BMS lines to the positive on each, basically where I'm creating these jumpers. I need to put 5 more BMS lines for all the positives. So I have a BMS line coming off of this negative, and then all the positives. So it'll be a BMS line off of the negative, and then this would be number 1, the first positive of them all. Number 2 would be this one. Number 3 is this one. 4, 5, 6, 7, 8, 9, and then the positive, this last one will have one as number 10. So that's the plan. And like I said, the biggest thing is just really take your time. Make sure it's the way you want it. It's all kind of squished together and tight. And then think again to make sure that this is exactly what you want. Because I need to go from these positives right here to these negatives. And I don't need to touch anything else. That's the big scary part. So it needs to go like across here. But you need to be super careful not to touch anything else, because right now all of this could, is exposed. I cut a bunch of these to length so I could put these down, and you just want to make sure you don't touch anything around them. So you want to make sure this is the right length and everything's good. So with this one, you've got all of these positives going to all of these negatives. So this is the very last cell and this is the very first cell. So if you do a longer one across right here, you're touching the 2 negatives and the 2 positives of the cells that you want to connect. Just like this. And you could, strip the metal however you want to strip the metal to make sure that you do not touch anything else other than that. And then you just use your spot welder and go right down the line. And that's it. So depending upon how many you want to do, my thought was that I would try to connect probably 4 for each, and I feel like you want to probably do the, like a couple at the farthest ends, and then maybe a couple in the middle. So it's up to you on how many you think you need, but again, you got these positives and these negatives you need to connect, so you want to make sure that you don't accidentally jumper to one you don't want to touch. So like this one would be the kind of the farthest end in one direction. And then you can do one farthest end the other direction, and just recheck yourself every time. It's like, all right, we've got these positives and these negatives, so we don't want to go past. So we would want to do these 3 and make sure you don't accidentally go a little too far. You could even snip a little bit of the corners just to make sure that they're not reaching out too far. Right? Because you've got 2 positives and a negative here, and you do not want to accidentally go all the way to this one, because then you're going to let the sparks fly, and that's no fun. So then it's up to you on kind of how you want to do, if you want to do any more or not. I feel like maybe it wouldn't hurt to do an extra one like here. So it's just, I think 4 is probably plenty. And so you've got these positives and these negatives. So you want to go, say, from this one to that one. And again, you might want to trim the corners a little bit or something, but this one just take your time and make sure you get it exactly right, and that you're not running the risk of touching another bank of cells that you're not wanting to touch. And that's it. So now we've successfully connected these first two. And then the only thing left to do is to add the BMS line to the negative. And then anywhere along here, I tend to try to avoid touching the batteries as much as possible. So I usually put the BMS line between, like I could solder or grind just a little bit to rough it up. And then I'll put some solder right here between the cells and then run the BMS line right off of this. And I'll do that on each one so that I'll have 5 more sets of BMS lines plus the negative. I'll probably solder onto this or something to get the negative BMS.